Hello everyone. In this video tutorial, I will demonstrate how any kind of counter-cross interdiffusion reaction at the interface of a diffusion couple can be simulated using equilibrium module of Fexage. The primary assumption of this kind of calculation is that the diffusivity of all components in both materials are same. So using Fexage equilibrium module, we can predict what kind of phases will develop in this interface region of the diffusion couple during interdiffusion experiments. For, for this problem, we will take the first alloy to be aluminum magnesium alloy with molar composition to be 0.97 aluminum and 0.03 magnesium, and the second alloy to be Az31 alloy, which has composition of Mg 0.965, aluminum 0.03, and zinc to be 0.005. So first we will open the equilibrium module of Fexage by left mouse click on the equilibrium button. Then we will select the databases for this kind of calculation. To select the databases, we first go to data search option here and left mouse click on this option. Here we will select FT-Light as our database because these are light metal alloys, and then after selecting the database we'll click on OK. Then we have to input all the reactant species. So in this case, to input reactant species, we have to go to add new reactant button, which is the plus sign, and then click left mouse button to input new species. Here we will directly input the molar formula of both the alloys. The first alloy is aluminum magnesium alloy, which has composition, as I have shown before, aluminum to be 0.97 and magnesium to be 0.03. Next, we will input the composition of Az31 alloy, which has magnesium 0.965, aluminum 0.03, and zinc 0.005. Then we want to vary the amount of aluminum magnesium alloy in our diffusion couple direction, x direction. So we put the variable a, which is the variable to vary the amount in grams, and then correspondingly will vary the Az31 alloy amount by putting the total amount of material, which is 1 gram, minus the aluminum magnesium alloys amount, which is A. And after inputting all the reactant values, we will click on next. Here we first select all the solution phases. To select all the solution phases at once, we go to the select button and left mouse click on it and then select all solutions. Then we want to select all the pure solids. To select all the pure solids, we go to pure solids in this white region and then left mouse click on this. To see all the what type of pure solids we have selected, just go to pure solids text and right mouse click on it. Here we can see all the selected pure solid compounds. Then after selection, click OK. Now we want to vary our amount of aluminum magnesium alloy in our diffusion couple from 0 to 1, where 0 corresponds to the Az31 alloy and 1 corresponds to pure aluminum magnesium alloy. So in between 0 to 1, we'll vary it at 0.01 interval, and this variation in between 0 to 1 will signify the interface region, and we want to do all the calculation at a fixed temperature which will be 450 degrees centigrade. After putting all the input values required for the calculation, we click on calculate. So after the Faxes has given us all the calculated values, here A0, A equals to 0 corresponds to the Az31 alloy which has HCP A3 has one phase, ACV phase, and if you want to see what is the phase of aluminum magnesium alloy, we go to show pages, go to next page, here we can see that our aluminum magnesium alloy has FCC A1 hash 1 phase, and if you want to see what are the phases which is developed in the interface region, we want to plot the calculations with the amount of phases in our y-axis and the variation of our alloy in our x-axis. To do that, we have to go to the output, left mouse click on this button, then go to plot and then plot results. In plot results dialog box, when it opens, we have to select the axis which we want to put in our graph to visualize all the interface compounds which are generated. In order to do that, click on the axis button with left mouse click and then select y variable which will be gram of phases and click on refresh. In the x variable, we will have the variable a which is alpha. After selection, refresh and then click OK. So our axes are selected. Then we want to select all the species. To do that, we have to go to the select option, left mouse click on that. So this dialog box shows all the species which are taken in our calculation, and to select all the stable phases which are formed in the calculation, we go to the select option and then left mouse click on this one and select all the stable phases and then click OK. After doing that, we will click on plot to see the graph. Here in the plot, in the figure module, the FactSage plotted all the data, as you can see, from pure AZ31 to pure aluminum magnesium alloy. In the interface region, what type of phases are formed at what composition, it is shown in this figure, and that is how we can calculate simple interface calculation for diffusion couple.